Section 6.3 is about angle-angle similarity. So yes, you guessed it, we'll get back into proving, but this time we're not going to prove that things are congruent, but we're going to prove that things are similar. So we'll start with the postulate, angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So according to this, all you need to know is that two angles from two different triangles are congruent in order for you to know that the two triangles are similar. But if you think about it, the third angle would also be congruent because, like, let's say that this was 50 and that was 50, and this was 30 and that was 30. That means that there's only 180 degrees in a triangle, so that means that this angle and this angle would also have to be congruent. But you only need two of them in order to prove they're similar, because it would then be implied that the third is also congruent. So again, angle-angle similarity, and I would write it like this, angle-angle similarity, just like that, to abbreviate it. And here is example number 1, and we're actually going to have 4 parts. So here is part A. Show that the triangles are similar. Write a similarity statement. So we can see in this problem that we have two triangles where one is inside of the other, and we're given that they each have a 52-degree angle. So it often helps to draw the triangles separate when they are inside of each other like this. So here's the big one, triangle ADC, and the small one, triangle AEB. So we know that this angle is congruent to this angle because we were told that they were both 52 degrees. And then angle A would be congruent to itself since they share that angle right up here. So we only need two pairs of congruent angles in order to prove that they're similar. So we'd first say that angle C is congruent to angle B because we were given that they were both 52 degrees. Angle A would be congruent to itself because of the reflexive property. And then I'd be able to prove then that triangle ADC is similar to triangle AEB because of angle-angle similarity. So I didn't do a formal proof, but I did state how I knew the triangles were similar. And now on to part B. Show that the triangles are similar. Write a similarity statement. The only thing that we're given in this problem is that this side is parallel to this side. That's what the little triangles mean. Just like before, anytime I see parallel lines, I'm thinking alternate interior angles. So it might help if you turn your iPad to the side so you can see that this side is parallel to this side, and then we'd be cut by this transversal, and we'd also be cut by this transversal. And remember, alternate interior angles form a Z shape. So we actually have two Z shapes here that we can use. We can show that angle T would be congruent to angle R because of alternate interior angles, but we can also show that angle S would be congruent to angle U because of alternate interior angles. We could also show that this angle is congruent to this angle because we have two lines that are intersecting, and these two angles are across from each other. So if you remember that, those are called vertical angles. So I can actually prove here that all three angles are congruent. But remember, we only need two of them. So let's just show that angle S is congruent to angle U because of alternate interior angles. And angle T is congruent to angle R because of alternate interior angles. And again, I could go even further and say that angle TVU and angle RVS are congruent because of vertical angles. And we also have that theorem from way back when that's called the third angles theorem that states if you know that two angles are congruent in a triangle, then the third angle is also going to be congruent. But again, for similarity, we only need to show two pairs of angles are congruent. So now that I've shown that two pairs of angles are congruent, I can now state that triangle, let's start with the smaller one. So we'll go RSV. Since I started with R actually corresponds to T, so RSV is similar to triangle T, and then I put S next. S corresponds to U, so it'd be TUV, since V would correspond to itself. And again, I know that they are similar because of angle-angle similarity. And on to part C, show that the triangles are similar and write a similarity statement. So we see that this triangle is equiangular and this triangle is equiangular, but we do not know that these angles are congruent to each other from one triangle to the next. However, if you remember back from chapter 4, if we have an equal angular triangle, we know that each angle is 60 degrees because there's 180 degrees in each triangle. And if all three angles are the same, 180 divided by 3 is 60. So just the fact that we know that the triangles are both equiangular, we can show that each angle is 60 degrees, which means I have at least two pairs of angles that are congruent. So I would be able to state that angle F is congruent to angle Q, angle G is congruent to angle R, and angle H is congruent to angle S. And I don't have to show all three of those because remember I only need two pairs, but I'd be able to show that all three of those are congruent because the definition of equiangular triangles. So then again, I have at least two pairs of congruent triangles. So I would state that triangle GFH is similar to triangle RQS because of angle similarity. And again, we knew this because we knew that both triangles were equiangular. So you can go ahead and assume that all equiangular triangles are similar to each other. And now on to part D. We're still showing that the triangles are similar, and then we'll write a similarity statement. So you can see here we have two triangles that are sharing a side. So we're going to show that this triangle is similar to this triangle. So to start, we see we have a right angle. Because that would be a linear pair with this angle over here, we can assume that this angle is also 90 degrees. Also, if we have a 32-degree angle here, we can find this angle by taking 90 minus 32, and we'll get 58. And then on the same side of that, since this is 90 and this is 58, I can find this angle by taking 90 minus 58. So here again, I can actually show that all three angles are congruent, and therefore the two triangles are similar. But remember, we only need two pairs. So we can state that angle C is congruent to angle, it would actually be FDE because there's more than one angle D up there. And then we can also show that angle E is congruent to angle, and again, I'm going to have to call it with three letters because there's more than one angle D up there. So it would be angle CDF. And that gives me my two pairs that I need to be able to show then that triangle. We have to write it in corresponding order. Let's do CDF is similar to triangle. If I started with the C corresponds to the D. So D, and then I went to D after that, which D corresponds to E in the other triangle. So it'd be DEF because of angle similarity. And let's move on to our last example, number 2. A school building casts a shadow that is 26 feet long. At the same time, a student standing nearby, who is 71 inches tall, casts a shadow that is 48 inches long. How tall is the building to the nearest foot? So notice first that we were given the shadow that the school is casting is 26 feet long, but then we're given our two other measurements in inches, so we're going to do some converting. But first, as always, let's draw a picture. So here is the school, and we know that it is casting a shadow that is 26 feet long. And then there's a guy standing next to it, or standing nearby, that is 71 inches tall, and his shadow is 48 inches long. So 71 inches right here and 48 inches down here. Next, let's go ahead and convert that 26 feet into inches. So there are 12 inches in a foot, so I'm going to take 26 times 12, which you end up with 312 inches. And just as a reminder, we were asked to find the height of the school building. So just think about the fact that we have the sun that's up here, and it is hitting the building and the guy at the same angle. So if we were to draw this triangle, since it's the same time of day, you can assume that this angle that is being formed by the sun hitting the side of the building and the guy would be congruent because of the angle at which the sun is at. So we could have one pair of congruent angles, and we can also assume that this is a right angle and this is a right angle. So now we know that these two triangles are similar because of angle-angle similarity. So we can actually set up a proportion now to find this missing length. It would be x over 312 equals, since this side corresponds to this side, I'm going to put 71 on top, and then all I have to do is cross multiply to find x. So I'm going to cross multiply here, so I would have 48x equals 22,152, and then I would divide both sides by 48. So you end up with x equals 461.5. Remember, we converted everything into inches, but we were asked to find the height of the building to the nearest foot. Since there are 12 inches in a foot, I'm going to take this answer, 461.5, and divide it by 12. So after dividing by 12, I end up with, since I'm kind of running out of room, I'm going to write it up at the top here. I get 38.4, so it says to the nearest foot, so I'd say it's about 38 feet tall. And that's it for this section. Make sure you jot down anything you don't understand so we can cover it in class, and we'll see you then.